Good day to our beloved students. Welcome to our math class. It's a great pleasure for me to teach you and give you the learnings needed for our today's lesson. Our objective is to use trigonometric ratios to solve real-life problems involving right triangles. And in this video, we will focus on the tangent and cotangent ratio. Are you ready? To further understand the lesson, okay, let's get started. Our lesson is all about using the trigonometric ratios to solve real-life problems involving right triangles. What are the 6 trigonometric ratios? What do you call the ratios of the opposite side to the adjacent side of a right triangle? How about the ratio of the adjacent side to the opposite side of a right triangle? Knowing and familiarizing in solving trigonometric ratios like tangent and cotangent will help us to answer real-life problems involving right triangles. For us to recall our previous lessons and the 6 trigonometric ratios, let us fill the blanks with the missing term or terms for each statement. For number 1, the blank is the angle formed by an upward line of sight and the horizontal line. What do you think will be the answer? If your answer is angle of elevation, then you are correct. For number 2, the blank is a triangle formed by the downward line of sight and a horizontal line. Can you guess the correct answer? If your answer is angle of depression, very good. That's the right answer. And for number 3, blank is the ratio of the opposite side to the adjacent side of a right triangle. Have you figured out the answer? If your answer is tangent ratio, that's correct. Let's proceed to number 4. Blank is an imaginary line that connects the eye of an observer to the object being observed. Have you figured out the answer? If your answer is line of sight, you got the right answer. And for our last number, in angle of elevation, the object being observed is blank, the observer, while in angle of depression, the object being observed is blank, the observer. Can you guess the 2 missing words? Okay, let's complete the sentence. In angle of elevation, the object being observed is above the observer, while in angle of depression, the object being observed is below the observer. Now, let us analyze carefully the given illustration below. What sides of the right triangle are part of the given problem? The sides of the right triangle that are part of the given problem are the opposite and adjacent sides. What trigonometric ratio can we use to find the height of the flagpole in the given problem? We can use tangent ratio since the opposite and adjacent sides of the right triangle are part of the problem. What is tangent ratio? Tangent ratio is the ratio between the adjacent side and the opposite side of a right triangle containing that angle. The tangent ratio is the value received when the length of the side opposite the angle is divided by the length of the adjacent side to the angle. We use the tangent ratio formula tan theta is equals to opposite divided by adjacent to find the unknown measure of one of the legs of a right triangle given the angle, and the measure of one leg of the right triangle, or to find the unknown measure of the angle given the two legs of the right triangle. Now, let us try to find the height of the flagpole. Based on the given illustration, the angle of elevation from the point where the boys stand to the top of the flagpole is 40 degrees. The distance from the point where the boy stands to the base of the flagpole is 25 feet. As you can see, the sides that were part of the problem are the opposite sides and the adjacent sides. Therefore, we use tangent ratio to solve the given problem. Remember that in tangent ratio, the opposite side is divided by the adjacent side. Then, let us set up an equation by substituting the unknown and the given to the equation. Substituting, we have tangent 40 degrees is equal to x divided by 25. Then, we multiply both sides of the equation by 25 to isolate the unknown on one side of the equation. We have 25 multiplied to tangent 40 degrees is equals to x. Solving, we have x is equals to 20.98 feet, or simply 21 feet. Therefore, the height of the flagpole is 20.98 feet, or 21 feet. Let's have another example. In this given problem, the angle of depression from the top of the building to a fountain is 30 degrees. The fountain is 47 feet from the base of the building. Find the height of the building. The opposite side and the adjacent side of the right triangle are part of the problem. Thus, we use tangent ratio to solve the problem. Remember that tangent is equal to opposite side divided by the adjacent side. Then, let us set up an equation. Doing so, we have tangent 30 degrees is equals to x divided by 47. Then, we multiply both sides of the equation by 47 to isolate the unknown on one side of the equation. Thus, we have 47 multiplied to tangent 30 degrees is equals to x. Solving for the value of x, we have x is equals to 36.72 feet. Therefore, the height of the building is 36.72 feet, or simply 37 feet. Now, let's proceed to the third example. The angle of elevation of the sun is 25 degrees. At the same time, how long is the shadow cast by a coconut tree 15 feet high? Since two legs of the right triangle are part of the problem, we use tangent ratio to solve the problem. Then, let us set up the equation by substituting the unknown and the given to the equation. Thus, we have tangent 25 degrees is equals to 15 divided by x. Then we multiply both sides of the equation by x and the reciprocal of tangent 25 degrees to isolate the variable on one side of the equation. Doing so, we have x is equals to 15 divided by tangent 25 degrees. Solving, we have x is equals to 32.17 feet. Therefore, the length of the shadow cast by a coconut tree is 32.17 feet, or simply 32 feet. Now for our last example. An airplane is flying 4 kilometers above the ground. The distance along the ground from the airplane to the airport is 6 kilometers. What is the angle of depression from the airplane to the airport? Here, the missing value is the measure of the angle. As you can see, the opposite side and the adjacent side of the right triangle are already given in the problem. Thus, we use tangent ratio to solve the problem. Setting up the equation using the given on the problem, we have tangent theta is equals to 4 divided by 6. Since the unknown is the measure of the angle of depression, we use the inverse trigonometric ratio of tangent, which is arctangent, to the quotient of 4 divided by 6. Thus we have angle theta is equals to 33.69, or theta is equals to 34 degrees. So those are the examples on how to use trigonometric ratios to solve real-life problems involving right triangles. To sum up our lesson, remember that tangent ratio is the ratio between the adjacent side and the opposite side of a right triangle containing that angle. The tangent ratio is the value received when the length of the side opposite the angle is divided by the length of the side adjacent to the angle. We use the tangent ratio formula tangent theta is equals to opposite over adjacent to find the unknown measure of one of the legs of a right triangle given the angle and the measure of the other leg of the right triangle, or to find the unknown measure of the angle given the two legs of a right triangle. So that ends our lesson in using trigonometric ratios to solve real-life problems involving right triangles. I hope that you enjoy and understand the lesson that we have discussed clearly. If not, you may go back to the lesson presented. If the lesson is clear to you, congratulations! You may now proceed in answering the exercises given to you in your module. Again, this is Mr. Herbert Evangelista, your math teacher, saying good luck, stay safe, God bless, and enjoy learning. See ya!